Today's subject is all about rotary converters. This one converts low voltage DC to high voltage DC. I've zoomed in for a closer look. So this is one end, it's got a commutator, and we go around the other end, it's got another commutator on the other end. When I first bought it 10 years ago, it was one of the most strangest things I've ever seen, and I had no idea how it worked. Here is a view of all the input and output wires to make it work. Now I'll pull off the cover and we'll have a look inside. That's the view inside, where all the wires from here go into there and then back out again. Here is a close-up of the nameplate. It's made by General Electric and they call it a dynamotor. It's 28 volts DC input by 19 amps. It's 1000 volts output DC, 0.35 amp. And it's rated for 1/2 hour use. Here's a close-up shot of the cover. It's got a warning on it. It says, "Danger, high voltage. Do not remove this cover while dynamotor is running, or replace fuses while equipment is turned on. Good advice with 1000 volts DC potential." Here is a bit of a detailed explanation of where the wires go. That one there is 24 volts positive, that's 24 volts negative. These are the two fuses for 24 volts. This is the contactor that switches the low voltage side on, and this here is the high voltage fuse for 1000 volts DC. Here are some spare fuses that came with the rotary converter. It's for the Signal Corps US Army, made by General Electric Company USA. The first thing I did after I purchased this rotary converter, check the fuses. That one's okay. That one's okay. The low voltage side's okay. And then I checked the high voltage fuse. There's a problem with it. After I checked the fuses, I wanted to see if the motor was going. So what I did, connected up a 12 volt battery, but because it's a 28 volt system, the contactor won't work. So I bypassed it, and we'll do it now, and we'll try it. Nothing there, and the motor's working. So I've got the 24 volt side working, but because the fuse was faulty, I assumed the worst, and because I was totally ignorant of how these things worked, I assumed somewhere the windings in the motor or generator were faulty. So I thought it was time to throw it out, and it sat in my shed for 10 years. Right, we'll fast forward up to 10 years to the present time. I now know how these rotary converters work. This is a DC motor. It's got your commutator and brushes, and you feed power through the brushes, goes through the windings, and it acts as a motor. Now how a rotary converter works is you have windings, extra windings in here, and an extra commutator over here. So there's two distinct and separate windings. One acts as a motor and one acts as a generator. Here is a view of the low voltage side commutator and brushes. We know this works. And that there is the high voltage side, and that's what I'll test now. The first thing I want to do is to see if the high voltage generator works. I've traced out the wires from here to here. These are the two brushes going to the suppression capacitors. So I'll give the armature a bit of a flick. There it works. We're getting about 2 volts. So now I know the high voltage generator works. If I can connect 24 volts DC, it should work. So now I've come to the testing stage of the high voltage generator. I've installed a 240 volt globe This generates 1000 volts, so if I put only 12 volts on, in theory I should get 500 volts, and see if the globe will stand it. Oh, look at that, it works. You've got 400 plus volts. Now I'd like to use the heavy duty contactor. These are the two control wires. Take them over to here, and then out this bundle of wires here. Now all I need to do is trace the wires from the contactor to these wires here, which will probably switch it on. So we've got nothing there, nothing there, nothing there, there, there. Oh, there we go, that's the one just there. Now we can connect up 24 volts. Now I'm ready for the big test. There's the 24 volt battery. Pan over to here. They're the two input leads for the battery into 24 volts. And what's a bit hard to see here is this part here. This switches on the contactor. And what I've done is one wire comes out there through series, goes through 4 240 volt globes, so it makes it 1000 volts, and then terminates up the top at the fuse. So we'll try the big test and switch it on. Oh, look at that, 1000 volts DC, it works. I would like to put a multimeter on there, but none of my multimeters will go up to 1000 volts DC. Now that I know that the rotary converter is working, I can add it to my collection of vintage electronics. But I would like to ask the question, why would anyone need 1000 volts DC? If there's anyone out there who can enlighten me of what these rotary converters were used for in the army or in defence forces. I suspect it may be for radios, but I could be entirely wrong.